Okay.
It's already recording.
Can you guys hear me?
Yeah, but 2 microphones, 2 cameras. No microphone right now.
How about now?
Yeah, now
It's just that I need to turn off the room just a second. Into the room. Okay.
We approach the team.
Better? Can you guys hear?
Yep.
Do you still have echo?
Not
Have echo or no echo?
no echo.
Okay. I see a okay from Stanko. That means you can hear me, I suppose. Just a second.
Loud and clear.
Awesome. Thank you so much. Now I can hear you guys as well. Okay. So let's do this. So basically the idea here today was for us to, let's do this. Let me invert. That's better. Okay. So Miloš and the rest of the team, they mentioned they were interested in using Mongo in the Gorman project, right? And we decided that, okay, let's onboard the new team into Mongo, and why not take this opportunity to share with the rest of the working company team about things that we are already using on Mongo or things that we learned about Mongo that might be interesting. So the idea for this first hour will be for us to go through some slides, and please stop me at any point that you wanted to comment on anything. It's informal. I didn't have much time, so I create very rough slides, but they will serve as a base for us to go through the information here. So hope that helps. Okay, and let me share my screen, just a second. Screen share. Boom. Hopefully you're seeing some slides now. Okay, awesome. I can see Stanko's thumb saying, okay. Okay, so what I learned about Mongo, before the project for GiveWith, I had almost zero exposure to Mongo. I just installed it, put some JSON data inside, retrieved some JSON data, and that was about what I learned and what I knew regarding Mongo. But during GiveWith, I learned a lot. I read 3 or 4 books about Mongo. By no means I'm no expert on Mongo, but I learned enough to see that it's a very valuable tool. It was not hard to learn. It was easy to learn. It's very powerful. It's well documented. So I think it's going to be useful. So I organized the slides for our discussion in 5 interesting topics. First, what are the main features, like a 10,000-foot view of what's Mongo all about? Then a couple of examples that we are using Mongo for. Then some examples of applications, more sophisticated applications where other people use Mongo. Then an overview of tooling and some documentation entry points, some interesting books. And last, for GiveWith, we're using a cloud environment provided by the makers of Mongo called Atlas. And it's been very useful. So I want to talk a little bit about that environment as well. Okay. Let me just Just a second. I wanted to minimize this. And I want to turn off notifications. Okay. Okay, so regarding main features. So if you go to Mongo's website and you download the latest report about Mongo 4.0, Mongo 4.0 is the latest version for Mongo. And we just migrated from 3.4 to 4.0, and it was seamless. There were no problems regarding the migration at all. It was awesome. But there's a lot in here. We don't have the time to go into detail for everything, but I'll mention just some that I know and some that we were using. So first, Mongo is a NoSQL database. So it stores documents that have the same structure as JSON objects. The difference is that Mongo works with the binary JSON format internally. That means beyond the native JSON data types, such as float, string, arrays, those things, Mongo adds some object types, such as date and time, object ID, and those things. So you need sometimes to do some adaptation, and it also has some support for decimals, which means when you do not want to lose precision, especially when you're dealing with currency values, money, you need to be exact on the cents. Instead of storing floats, you could store decimal objects. In the case of GiveWith, we started with decimals, and later we fall back just to floats because we didn't need that level of precision. So Mongo has something interesting that we're not using in GiveWith yet, but it would be useful, which is document level validation on the database itself. So you are capable of storing a JSON schema that describes the shape of your data, the structure of your data, and the database can give you feedback if you are compliant to a schema or not. Another thing that we're going to see in detail, it's lookups. So one of the classical things that we have in a relational database is like joins, and that was one of the problems with NoSQL database, especially document-based database, where the model, the data model, is that you store a document as a whole and you don't have joins at the database level, meaning that if you have a reference in one document pointing to another document, then how does it work? And lookups solve that problem. The aggregation pipeline is another very powerful feature from Mongo. It allows you to create a map reduce like of processing style. So when you need to do some analytics, for example, you can use the aggregation pipeline from Mongo. So we're going to give more details about the aggregation feature. There's a lot of profiling and monitoring tools. There is support for graph processing. So if you're dealing with social data or any data that's mapped in a graph network of objects fashion, you can use some graph lookup primitives to go and look for documents navigating the graph structure from within Mongo. We're not using that yet, but it's super useful. If you need sorting according to some natural language or a particular vocabulary and alphabet, Mongo supports collations as well. Mongo does not support SQL-like, but the basic primitives from SQL, which are selection and projection, they are supported in terms of Mongo internal operators. And there's a bunch of other operators that you can use to create imperative MapReduce-like queries. So the approach is completely different than a SQL database where you declare the expected results and the database itself compiles a query that translates what you declared into a sequence of iterative steps that are going to be performed. That's how the SQL relational word works. But in Mongo, it's much closer to a programming language where you create this pipeline of operations, and every stage transforms all the documents into a new shape. And then the next stage will transform into another shape, and then you get the result in the end. So it's much more like a regular programming language where your program is the query and it runs inside Mongo. We talked about data validation and schema validation. If you need to restrict access control, there are some interesting ways to do that. IP whitelisting is one of them. And the newest version of Mongo have some interesting features. One of them is finally support for transactions. So if you are dealing with multiple documents and you need to do an operation that's all or nothing, that involves those two documents, then you can do it inside a transaction. That was a pain point for NoSQL databases before because they were not transactional. So when you were dealing with one single document, you had guarantees, but when you were dealing with multiple objects, they were not having that it would execute atomically. And with Mongo 4.0, you have that. Another interesting thing is that sometimes in the JSON file, and I think I'm going to stop my video just to make the bandwidth a little bit better. I don't know if it's spotty for you guys. Okay. And okay, so the pipeline type conversions are solving a problem that we had, we received the JSON from the UI and we need to create some type conversions, some typecasting at the API level before sending that data into Mongo. And now with aggregation pipeline type conversions, we can do that within the scope of the query. That's super useful. And the non-blocking secondary reads, it's regarding Mongo uses a replica set structure. So you can have a standalone database, but you can also have a replica set, which means multiple instances of the database serving the same data into a parent-child fashion, or you can do sharding. We haven't done any sharding into GiveWith project because the scalability needs of the project didn't require that. But if you have big data, then sharding is an option and it's supported by Mongo. For those that do not know, sharding basically simply gets one collection and spreads that single collection across multiple databases instances. So in that case, you have a criteria to route the data to a particular instance. And when you do a query, it goes to all instances and retrieves information from all the instances. That's different than just having a replica set for high availability where you have this master instance where you're doing all the writes to, and internally they are replicated to the slave instances. And then if the master fails, you can use one of the replicas, or for better throughput, you could, in your program, in your API, you could specify saying, hey, I want to read from the primary, from the master, or in this particular case, I want to read from the secondary to decrease the loads on the primary instance. So that's also supported at the Mongo API level. So this is another view of those features, and it gives a glimpse of the future of Mongo. So we are right now on Mongo 4.0, and all of those features are supported, but there are some things that are not supported yet in the last column. So it's just to give you an idea about how Mongo is going to evolve into the future. So sharded transactions, it's on the pipeline. It was not a blocker for us, and there are other features there, in case you're interested. This is something I came across yesterday, and I really do not know much about, I must confess. But what caught my attention is that they are thinking about a solution for mobile applications where data locality is super relevant, and sometimes it's hard for us to create the data synchronization across the local storage in mobile applications and the database on the cloud. So they have this solution that's called Mongo Stitch and Mongo Mobile that it's interesting for us to explore as well as a company. Okay, so let's take a look about what it means to use Mongo. So most of us use Mac. So installing on Mac is pretty similar to installing this on Linux, installing this on Linux. You simply can grab the latest tarball, unzip it, and then start the Mongo daemon. So if you do this, you have a local Mongo instance running on your machine, and it's ready to use. Now, I'm going to show you very quickly a bunch of code snapshots. Because GiveWith was using Mongo in Clojure and Python mostly, my examples are in Clojure and Python. We also used from Node, if I'm not mistaken. So Stanko might be able to share later some access code or impressions about using Mongo from the UI. But it was, I think, it was maybe just small queries there. Most of them are going through the API, and our APIs were in Clojure and Python. So this example here, it's just to give you an idea about how do you connect to the database. Basically, you instantiate a client, which is the client variable on the top, and then you can create a client connection. Will have access to multiple databases inside Mongo. You can have multiple databases, and they can be disjoint. We use that feature for developing separate independent APIs on GiveWith. So inside the same instance, we had one instance for development environment, for CD, another instance for QA, and on each instance, we had separate databases for separate independent APIs. That was super useful. Once you get a connection to a particular database, you can instantiate the collections. So each collection, it's pretty much like a table in a relational database. And that table will have documents. And those documents can have the same schema or disjoint schemas. And that's a characteristic of NoSQL databases. So it can be an advantage. And in the end, it's an example of how to insert a record. So basically, campaign is a dictionary. In this case, was in Python. And the Python Mongo driver performs the conversion between a Python data structures into a JSON data structure. And then it sends that data structure to Mongo. And that's it. In this other example, the only relevant part is the second line close to the end, where you see collection campaigns, replace one, filter, and replacement. So basically, the driver API will give you some primitives to perform updates, to perform inserts, and you even have the ability, when performing an update, to send a parameter saying, if I'm updating this record, but if the record do not exist, then create the record. So it's something that you can do on the API as well. This is another example that I just mentioned. The relevant line is the one close to the bottom where we are saying update one. Call campaigns, update one. And the relevant part here is that on the update, you first define if you're updating everything or a subset of documents. So in that case, I'm updating a subset of documents, just the ones for which the object ID will match. And when there is this match, what I want to do is to change just the contents of one field, which is the field last added. And I'm setting the current date. Another hint that I give you all is always use a single time zone, and we are using UTC for obvious reasons. And Mongo by default uses universal coordinated time as well. So in your API, if you use UTC, you're fine. And just on the frontier of the API, you translate to a particular time zone if required. This is an example of the new feature where you have transactions. So this example is in Python, but it's supported across all supported languages, Java, Clojure, Python, Node, etc. And it's what's expected on a relational world. So you start a transaction, and then you commit the transaction, and if something goes wrong in the middle, it's an all or nothing operation. So this is new for Mongo 4.0. We didn't have that before. This is just an example of portability. So we have a query now. I'm sorry, this is a more complex query. So this is what I mentioned regarding the aggregation pipeline. So the example here is in Python, but the query itself is a JSON document. So a translation for this into JSON, it's almost one-to-one. And each partial, we have an array of objects here. So the query is this array of objects. And the first object, the match campaign ID on the top, it's what we call the stages on the pipeline. So the way to understand this is for each object on that array, Mongo will perform a transformation of the data. Imagine that we have a string of data, and each page will transform that string of data into something else and feed that to the new stage. So in the beginning, we're filtering out just the campaigns we're interested in. So a lot of objects are going to be discarded at this point. In the second stage, we are doing a more advanced filter where we are considering dates. So we want to apply a date range. On the third stage, we're using the unwind operation. And that's particularly interesting because in Mongo, you can have arrays within documents. So the unwind operation, it's getting the object that you have that has a nested array, and then it's creating multiple objects with the same signature, but instead of having the full array, each new object will have a single element from that array. That's why it's like unwinding. It's unrolling the array. And since we have nested and nested arrays, we're doing two unwinds. And then we reach the project stage where we're saying, hey, now that I unwind a lot of things, my objects are fat, my documents are fat. I want to cut out the fat and just preserve those fields. And once I've done that, I can add some new fields, and then I can do string concatenation operation. So I'm creating a new ID by concatenating strings. And all of this is happening inside the database. So we're leveraging locality, and it's super performant. Then we do another match, and then we do a group by operation. It's the same group by that we have in programming languages or in relational databases, where we have this stream of objects that now we want to group them into single objects. And we need to define what's going to be the ID for the grouped documents, and then what do we need to do, because how do we group them? So sometimes we create new arrays and use a push operation. Sometimes we simply sum up values that we have in individual objects, and the grouped documents will have the summation of those values. That's what you're doing here. And then in the end, we receive just the groups, just the summary. So this is a real world analytics performed inside Mongo. This is another example, and now I'm showing portability. So the previous one, this one is Python, this one is Clojure, and it's almost the same thing. We are creating the stage of the pipeline processing. In this example, the only difference is that we're doing something fairly sophisticated here, which is the index of array operation. It's going into one nested array in the object. Imagine that I have this array with values on that array. And then I try to figure out from that array, what is the index that has some value inside. And then I'm going to use that index value in another expression. So if I have two arrays and I need to make some correspondence piecewise between those two arrays, I can do this inside Mongo. So I have the value impressions, I go over the array, I see where the impressions is, let's say it's on the third position, so number 2, 0, 1, 2, 2 will be the third, will be the impressions index, and then I'm using impressions index down on the query to index a different array and gets the corresponding value. So this is a very sophisticated operation that now we can do inside Mongo. And the relevancy of this is that imagine that you got JSON data from the outer world, which is our case here. So one of the APIs, in this case, AddForm API, gave me data organized into separate arrays that correlate between themselves. So I didn't need to do any. What we done was to do the processing within Mongo. So this is super cool. This is another example of a pipeline where we have two nested grouping steps. So there's this hierarchy of groups that we're creating here. That's also super useful. And those pipelines, this is another way to illustrate those pipelines. So if you're using Mongo tooling, it is available. Oh, the slide update. Can you guys hear me?
We can, but it's not that great. It's clipping a little bit.
The last 15 seconds, maybe.
Yeah, just for the last minute or less.
Okay, so I noticed because the slide did not. Let's see if it's better now. So if it gets worse, please scream.
Yeah, it sounds better now already. So let's try.
Okay, so this is an example of the pipeline. So this is a tool from Mongo. We haven't used that before, but after I knew it existed, I had to show you guys. So imagine those queries now translated into this tool. Each row is one stage of the pipeline. And then on the right side, you're having samples of the documents. So if you go from top to bottom, you're seeing the transformation that each document suffers when we apply the pipeline stage on the left. So first we have a match on the second row, then we have a projection on the third row, and then we have a sorting on the fourth row. And on the right side, you see how those documents evolved as we moved forward on the pipeline. So this is great for debugging your query if it's an aggregated query. This is an example of Mongo documentation. It's really, really good. And in this particular one, I'm highlighting the lookup operation, where on the top, we are creating this database with three documents. So we're inserting on the top, like a record 1, 2, and 3. And on the second group, we are going to a different collection. So first we have the orders collection, and then in the second one, an independent collection called inventory. It's separate. And then we create an aggregate query on the first collection that's going to do a lookup on the second inventory collection. So this lookup stage, it's a way to do joins within Mongo. So this is something Mongo did not have before, and what made the NoSQL world get closer to the relational world, because it's actually a join operation. And in the end, you see the resulting document. And in this other example, we're doing a lookup, but interestingly, we're doing a lookup within the same collection to process a network of relationships. So in this case, we are creating a graph structure. So each document is an edge of a graph. So you see that Elliot points to Dev, Ron points to Elliot, Andrew points to Elliot, and so forth. And then on the second row, we have the aggregate query doing a graph lookup that will traverse that collection. It will navigate the graph. It will start from the node, it will use reports to as the type of edge to navigate. It's using the employees collection, so that's the graph we're interested in. And then it's going to navigate through the reporting hierarchy and constructing that graph. And in the end, you can see that the closure, no pun intended, named reporting hierarchy that was captured from that graph traversal expressed from the graph lookup. So this is cool because now if we have graph data and we have document data, we can put both of them inside Mongo. And we can use Mongo as a regular NoSQL key value store, but we can also use Mongo as a graph database. So we don't need to use graph DBs, external graph DBs. We can do everything inside Mongo. This is one example. This other guy here, it's interesting because it's using geolocation. So this is something that we haven't used in Mongo. It's in there, so I mentioned to you. I have used geolocation in Postgres before because Postgres, a relational database, has an extension called PostGIS, Geographical Information System, that supports geographical operations. So geographical operations, basically you have this coordinate pair, X and Y. In this case, it's captured on the coordinates thing. And then you want to do things like there is a radius, and I want to know how distant these are, or if these two points intersect or touch, those type of things. So in this case, they are now supported in Mongo. So you have at least the geonear operation, which is basically a radius, a spherical radius. So depending on your needs, you use Mongo as a graphical information system database. Okay, so let's give some examples of broad applications. And all of these examples I took from a book that I'm going to present as well. It's a very good book, it's very short, but it goes very deep, which is MongoDB Applied Design Patterns. It's the last book I read, and I wish it was the first, because it was exactly what I needed. So this is because Thiago Lucchini asked me, when talking about Mongo to be specific about some use cases where you can use the database. So I think this is super adequate. So let's go over them. So what's operational intelligence? Basically, operational intelligence, it was what we knew before as BI, business intelligence, and now we're calling just analytics. Usually it means that we need to capture data really fast because we have this stream of data that we need to capture. And later we need to process that, applying statistics on that data and get a summary, which is the so-called intelligence on that data. So what are the features that make Mongo interesting for those type of applications? First one is the right concern attribute. So what's right concern? When you're using the API for Mongo, you can specify if you want to do it synchronously, meaning your code will wait until that data is written to the database. And when the database finishes up writing that information to disk and finishes up spreading that information across the replica set, then you get a response. So that level will be the most safe, most robust, because you only get a response when you're certain that the piece of data you wanted to write propagated across all the replica set. It's the slowest and the most robust. And then you have various degrees of faster writes where you're relaxing those properties. One example is you ask Mongo to give you an okay as soon as the primary, the master instance, gets the data, and you're not concerned about replication. Second level is when you give the data to Mongo and you ask for Mongo to reply immediately, and you're not waiting for any other internal processing to happen inside Mongo. This is super useful for high-speed logging, where if you lose one log entry, it's not much of a concern, but you prefer to have like a higher throughput of writes. So being able to calibrate the synchrony of writing operations, it's super useful. Another thing that's relevant to say here is that Mongo has two special types of collections. When you create a collection, it can be a regular collection, or it can be a capped collection. A capped collection is a collection that you set a limit on that collection, saying, okay, this collection will be this big, but not bigger. And then Mongo performs a round robin. So when it's writing new records, if it reaches the limit, it will rotate and override the oldest record that we have in there to make sure it's not growing beyond your limit, your threshold. So this is super useful to create logs in Mongo, and this is what we're doing on Giving. So we have a separate database. So we have two connections, so they do not compete. One connection, it's to one database for data. Another connection, it's to a separate database just with logs. And in that database, all the collections are capped collections. And then they are super fast, and they do round robin writes. And we do not need to concern that at the application level. Other features are bulk inserts. We have the same thing in relational database where you're saying, okay, in order to be faster, all of these documents, all of these records, write them once. So the round trip between application and database happens just once. I mentioned sharding, I mentioned capped collections. Another interesting feature is the time to leave collections. So in the time to leave collection, you create a collection where you're going to store documents in, and then you create an index saying that each document will have a date and time field bound to that index. And in the index, we'll have the expire. So let's say that I'm only interested in have 1 hour old documents. If any document is older than 1 hour, get rid of it. So I can use a time to live collection for that. And I set the index for 1 hour. And that's it. Mongo takes care of periodically, every hour, cleaning up records that are that old. So this is super useful. When you need it, it's perfect. For e-commerce. So e-commerce is something that we're doing in GiveWith. So the reason that these 3 items here are red is because they were exactly what we needed for GiveWith. So Mongo was a good choice for the GiveWith project because we had commerce. We were creating a special purpose content management system, and we're dealing with online ads. So all of these features were just in handy. So for commerce, we have those features here. By data polymorphism, what we mean is that in a relational database, a table has a fixed schema. But in Mongo, it's a NoSQL document-oriented database. A collection has documents, and each instance of document can have its own schema. Of course, you can create a mess, but if you have some discipline, you can evolve a schema within a single collection. For example, you can either create multiple documents that have a type attribute, and then they have a sub-schema that's common and another part that is specific. So you could model like an object orientation inside Mongo using this type field. Or if your schema is evolving, you can even have a type or a version attribute that you create new records that are compliant to an evolution of the schema. And then your API, when retrieving those documents, it can see, oh, okay, this is an old version, I need to do a conversion, or this is an old version, it's not supported anymore, or it's not supported yet. So in that case, we can have a single database feeding 2 APIs. One that's legacy, another one that's under development. They're using the same database and they are filtering out the data just because the database supports evolving schemas. So this is super, super cool. We mentioned nested arrays. Another feature, I mentioned before the replica set. So in the replica set, we can read from the slaves or secondary units. Usually, we are just talking to master. So we write to the master, we read from the master, or we write and read from the primary. Master, primary synonyms here. But there are times that you can give away consistency for speed. So in those cases, one thing that you can do is to have faster reads from replicas, from secondaries, specifically in your code, and they are faster, but you don't have the consistency guarantee that the latest write on the primary already propagated to those secondaries. So if you need eventual consistency, this is an interesting resource. If you need total consistency, no problem, just read and write from the primary, which is the default. Because we have the document model, we can store any schema and we can separate data and metadata inside our document format. So we get this for free, not just on Mongo, but on any document-based database. Mongo has another feature. If you need to store files in Mongo, Mongo has a limitation of each document cannot be bigger than 16 megabytes in size. So if for any reason you have large objects that you want to store inside Mongo, they have this gridfs thing that manages the restriction of 16 megabyte limit for documents to create large documents. In GiveWith, what we end up using was S3. So our documents had references to S3 buckets. And then we did not concern about this limitation of the 16 megabytes per document. But if you want to store everything inside Mongo, that's an option. There's also support for textual indexing. We haven't used that, but if you don't want to go all the way using like Elasticsearch or Solr as a separate database specialized on textual indexing, you can use textual indexing native inside Mongo. Okay, all of those other things are just type of other applications. So social networking would be, let's create a Facebook wall type of thing. So you can do that in Mongo. And if you need to do friend of a friend types graphs, you can use the graph lookup feature that I mentioned before. It's one strategy. Another option that you have is to create a document that embeds the graph in itself. So you can have an adjacency list or matrix within one document, because Mongo supports arrays and arrays of arrays. And the last example in the book was online gaming, where you create this like multiplayer massive game where a character has an inventory of items and it's currently on a particular position inside a map. And in that book, they explain how to model that game just using Mongo records. It's pretty interesting. Okay, so let's talk a little bit about tooling. So the tooling that I have been using, it's one that is free. It's called Robo3T. That company has a more powerful tool. So Robo3T, it's just a poor man's IDE where you can connect to multiple replica sets. So here what you're seeing are all the replica sets that we have for Mongo on the cloud. We're using Atlas Cloud. So in my local machine, I had a connection to my local Mongo, the first one, and then I had connections to multiple environments there. And all the ones that are 4.0, it's because we migrated to Mongo 4.0, but we still have some pointers to older versions of Mongo. That was super useful. And this is what it looks like when I connect to a particular replica set. In this case, I'm connected to dev, and I have multiple databases on dev. So config, give with development, and logs are independent databases. And on give with development, the one that's expanded, you can see all of the collections. And when I click on one collection, for example, campaigns, I can perform a query. So on the top, you see DB collection, campaign, find, everything. So it's listing all the documents that I have on that collection. And then I expanded one of those objects so that you have a glimpse of what it looks like. And then you can see that it has nested objects and nested arrays of nested objects or arrays. You can do whatever you want. And then you can see the types on the right column. And there's pagination. So the usual that you expect to manipulate the database. Perform queries, perform writes. In this case, I'm showing you the other database with a collection that we use, a capped collection that we use just for logging. And in this case, we configure our API to provide log not as a string, but as JSON objects. So then it's super easy for us to perform queries on top of our logs. So that's also super useful. And the same company provides a much more powerful version of that tool. Robo3T is free. Studio, you need a license. A couple of members of our team are using Studio 3T, I'm not. But I capture some screenshots so you have a glimpse of what it looks like. So it's similar to Robo3T, but it's more powerful. It embeds lots of other features that better support aggregations, importing and exporting data, and so forth, and editing queries. This is an example of a translation of a SQL-like query into a Mongo query. No big deal. And in this case, the query is in JavaScript. So the connection, everything could be done from JavaScript or Node. This is an interesting aspect that Studio 3T supports. Sometimes you have this nested collection of objects and you need to compare objects. So Studio has a feature that allows you to compare object by object. So this is super cool. And this is another example where you're dealing with the various indexing options inside Mongo, where you have text indexing, geolocation indexing, and collations. Okay, so there are other tools. There's one called Mongo Compass. There is integration for those that use IntelliJ. There is native integration in IntelliJ and PyCharm. So within that environment, you can connect to Mongo and browse records as well. Pretty similar to Robo3T and Studio 3T. And let's talk just a little bit about documentation. So this was a very fine surprise that even after reading those books, I often found myself going to the Mongo documentation to understand the richness of its operators. So for example, if you wanted to understand what can you do with the aggregation operation, there are a lot of operators that are valid within an aggregate call. And then you have this detailed reference with examples on how do you use those operators. So it's super useful. I mentioned that I read 4 books, but 2 of them are most relevant. So I'm sharing those with you. This one, it's the first one I've read. I read the first edition, not the second edition. But even the first edition, I think you can find it for free online. And it's good because it's comprehensive. So it's a good way for you to understand what's Mongo all about and what are those features, how it's organized, how do you do sharding, how do you do indexing, how do you do insert queries, updates, one chapter just for the aggregation pipeline. So in terms of overview, it's the best one that I've read. And this other one, after you have this comprehensive view of MongoDB, this one's a very short book. It's about 200 pages long. It's very short. And it goes in depth on those examples I mentioned before. So how do we do social networks in Mongo? How do we do business analytics? How do we do a game, a massive multiplayer game? So it was useful to me to see how do you translate real world problems into Mongo. Last piece of our conversation, it's Atlas and the cloud environment. So this you need to pay for, but Work & Co already have an account there. So maybe in your project, you can use that account for your benefit. So we are using that extensively, and our client is using that as well. So what I'm showing here are some screenshots from the web interface through which we interact with the database as a service from the Atlas. And there you can create new clusters. It's super easy. Just click on the button on the top. And when you click on that button, you can specify how big is going to be your replica set. Amount of disk space, amount of memory. It's pretty much AWS just for Mongo. So then you create your replica sets, and then you have everything you need to monitor them. So in this case, I'm showing you the 2 isolated environments, one for working company, that we have multiple replica sets, which are our environments, so dev, QA, UAT. And then we have the production environments, staging and production, that are handled by the client. And you can see for each we have strong or not authentication, for each we have backup activated, so forth, and the sizes. So basically for Working Co, we have very small databases, but for production, we can set large thresholds. These are other examples that were very useful, especially when I just arrived at the project, to realize what's going on. So when something goes wrong and you need to figure out what's going on, the Atlas has a lot of support for us to realize what's happening there. For example, in the first week that I was working with GiveWith, we had a problem, a performance problem, and we tried to dig around what's happening. And the first assumption was that it was happening on the database itself. So we used that machinery, and that machinery showed us that the database was just fine. And that allows us to realize the problem was on the API and on the memory handling inside AWS. But if we haven't had that, we probably would put the blame on Mongo and did not find the real problem. So there are lots of screens. You can check connections, failures, network throughput, memory issues, CPU performance inside the instance, and you can customize that as well. So it's very powerful. They also have an IDE, similar to what I have shown to you for Robo 3T or for Studio 3T. This one is not as fast as when you're running the IDE on your local machine, for obvious reasons. This is a web version, but this might be useful when you need to give support and you're not on your machine. So from any cyber cafe, for anywhere you have internet, you can log in and perform some operations like doing queries, even updates. Another tool that we use extensively was the command line import and export tools, or the integrated versions on Studio 3T. And we use those to replicate data across environments. So for example, we had data on production and I wanted to move that data to the QA environment. So I simply did a Mongo dump on production and a Mongo restore on QA. So that's basically illustrated on the first two blocks there. You have the Mongo restore, the Mongo dump, and it seems complicated, but it's just a connection string. Basically, you just say user, password, database, replica set, addresses, and that's it. You even have some type of internal logging if you're using the Atlas, which is also useful for you to manage your instance, your Mongo instance. They have integrated backups. We're using them for production, but most of the time to manage our internal environments, we use the dump and restore features. Another interesting thing is that they have role-based access control. So, for example, your team has external contractors and you want to control the level of access that you have. For example, client should have full access, internal working code team has medium access, and contractors should have marginal access. You can control that through Atlas as well. And the last feature that we are using is the whitelist IP-based access control. This was important to connect Atlas to Venice so that the instances that you have on AWS, they go out with a particular IP range, and then you give restricted access just to that IP range. Or, for example, when I was working from home and I want to give myself access, I could add my static IP address to that list, and then I didn't need to go through the VPN. I could go straight to Atlas and have a faster connection. Last but not least, Atlas connects and interoperates with lots of services. For example, Slack, they have webhooks, so you can do some interesting integrations there. We are not using that for GiveWith yet, but it's there in case you want to use it. So this is 1 hour presentation. It was my overview of what it's Mongo, what it looks like, and where can you use it. And now I still have some time to kind of discuss. I don't know if the rest of the team wants to discuss anything, but it's on you now.
Well, first of all, Rod, we'd just like to thank you so much for this detailed intro to MongoDB. Well, one question for me would be, what do you think about future of Mongo in our company? I mean, because this training was a nice intro. I'm a little sad that there weren't more people, but it is what it is. So, given those use cases that you mentioned at the very beginning, I think this might be a go-to solution for many projects in working code. But what do you feel about it?
Yeah, I think so. I think the conclusion that we took from our experience with GiveWith is that Mongo has this very nice balance in terms of easy to use, rich tooling, feature set, and robustness. All desired properties that we want. So I know for a fact that we have at least two other competing databases that we can use. We are using Postgre relational database for Embraer, and we have a couple of projects considering using Datomic. So what are my impressions? First, let's compare Mongo and the relational databases. So relational databases are consolidated technology, so they are robust. They have excellent tooling, but they have one disadvantage in comparison to Mongo. First, most of our front end, it's JavaScript-like. That means JSON data structures are a natural data structure to be exchanged, especially between front end and API. In that case, Mongo has the benefit of also speaking the same language, because it's like a one-to-one translation between JSON and Bison, the binary JSON thing. So for us in GiveWith, it was very natural to just receive the JSON from the UI, adapt it a little bit, and store it right through Mongo. And I think this is a huge advantage for, in comparison to a relational database, where you're going to need to think on the schema and split the structure that we have on JSON across relational tables. This is, I think, a big win for using Mongo instead of using a relational database. And then the biggest reasons there were for still use a relational database would be joins, transactions, and geolocation. And we have all of them now in Mongo. We have transactions, we have some geolocation support, and we have joins. So really, I don't see any advantage for us to use relational database now. So at some point, I was the one to say, hey, maybe on GiveWith, we might need a relational database because of this and that. And we changed our mind when we went to study the technology, and we realized, hey, everything we need is already there. We don't need a relational database. So this is one thing. Now let's talk about Datomic. Last week, I went to a speech from, with Thiago from Rich Ricky here in New York. And he was selling Datomic with ions, and it's super interesting. It's very, very cool, but it has one catch. Datomic, it's basically a closure-related database. So if you want to use Datomic, you need to use Clojure. You need to store it on AWS, because Ions and Datomic Clouds, they are tied to AWS. So this is my first concern. So if you're dealing with a project that the team is trained in Clojure, and the features that we need, Datomic supports, and AWS is the choice of clouds for the client, we're just fine. But since our projects vary a lot, I'm personally more comfortable on being proficient on a technology that's more adaptable. And in that case, Mongo proved useful because we could connect from Clojure, from Node, from Python. We could run it locally on our machines or on AWS or on Atlas. So it seems to me, I like to put my money on a few set of tools just because my head is not big enough. So when given the choice, I prefer to know how to use a Swiss Army knife and just carry that on my pocket, than have a heavy bucket of tooling and carrying that around. So it seems to me that Datomic is a specific purpose database tool, and Mongo proved to be more flexible. So my recommendation will be, if you need flexibility, Mongo is a win. So for those reasons, I think Mongo is a great choice for most of our projects because it's very, very flexible and it's proven to be robust. But that doesn't mean that considering the needs of a specific project, we might make a different choice. For example, we need higher support for geolocation, and then PostGIS will be a much more robust and feature-rich solution than Mongo right now. So Mongo has some support to geolocation, but PostGIS is much more advanced. I did part of my PhD with geographic information systems, so I know that there are some operations there that are much better implemented. Another example, we might need more sophisticated graph operations. So maybe Neo4j will be the right choice because it has a graph-oriented language, which is Cypher, and even other graph-oriented languages that Mongo only supports graph lookups. So it all depends, right? But by all means, I think it's useful. I think it should always be considered as an option because it's so flexible.
Cool, thanks. Okay, more questions?
Anything else, guys? Pierre, do you have any concerns? I remember when we were discussing with the people in Rio, they mentioned that you might have any concern regarding the use of Mongo.
Well, no, I think one of the concerns was the setup for, the infrastructure setup of Mongo. But we proposed and we actually decided to roll with it to use actually the MongoDB Atlas. So that solves that issue for us. And I'm not sure, when I was comparing pricing, I mean, that's certainly one of the points that we need to take into consideration. But comparing to an RDS on AWS, the Postgre, I think it's very similar. I think it's based, depending, the parallel tiers cost the same. At least that was my impression. I just did a really, really quick look at that, but it didn't seem like there would be a difference.
Yeah, that's a good point. It's very hard, unless we had the same application using Mongo and using RDS, we would be able to actually compare if it would be cost effective to use one or the other. Because it's not just about how much you pay for storage, it's also about how much you pay for compute time and how much you pay for transferring data around. All of those things cost money in the cloud. And so solving that equation is not trivial. I think what we can do is have an overall estimate of the top costs, not accurate, but like bulk figures, and see if the client can pay for that or not. The impression that I had was that Atlas was not expensive. So the client never complained about paying for Atlas, not even when we created multiple environments with multiple versions of the Mongo database inside. So it seems to me it's at least competitive with the costs for RDS. And I think our main driving decision factors should not just be cost, but also ease of development and suitability to the problem that we're solving. Because if we just go for the cheap solution, but it doesn't connect, doesn't click with the problem, it will be more expensive because developer time will always be more expensive than the database as a service costs, in my opinion. So if it's easier for us, it's the best for the client.
Cool.
Okay, anything else, guys?
Well, I guess we'll have more questions when we start using Mongo. So
Of course, yeah, sure. What we can do, we can first address them on Tech Random, just because it's a way to expose Mongo to a wider audience. And if they get too verbose, we can either create a channel or a separate Slack channel, a dedicated Mongo channel or a separate Slack channel just for that. But in the beginning, my suggestion will be, let's exchange ideas, impressions, and doubts on Tech Random, just to get the attention of everybody else. And if it starts to disturb, we create a Mongo channel there. But by all means, post your doubts there. I don't have all the answer, not Milos, I suppose, but I think we will be glad to contribute with the little knowledge that we have.
Absolutely.
Okay, guys, so I think that's a wrap.
Yeah, there are no questions. Thank you again so much, Rod. This was amazing. So now the ball is in our court.
Okay, I'll post on Tech Random the slides and the link for the video that we recorded in case anybody else can join later, and then that's it. Guys, thank you so much for your time.
Thank you, Rod.
Bye. Bye.
Bye-bye.
Bye.